Newton's first law has to do with objects at rest and objects in motion. He noticed that objects at rest stay that way until something comes along to move them. He also noticed that objects that are moving continue to move in a straight path unless a force slows them down and stops them. Newton called this tendency of an object at rest to stay at rest and the tendency of an object in motion to continue moving inertia. You must overcome inertia in order to start an object moving. And you must overcome inertia in order to slow down and stop an object that is moving. So Newton's first law of motion states that if no unbalanced force acts on a moving object, the object will continue moving at the same speed and in the same direction. And if the object is not moving and at rest, it will remain at rest until an outside force acts on it. A spacecraft will continue moving through space at a constant speed and in a straight path without the need for engines. Because there is little matter in the vacuum or emptiness of space, there is nothing to slow the vehicle down. Once the craft is away from Earth's atmosphere and its gravitational pull, the engines can be turned off. It will continue at a constant speed and in a straight path. Only if the engine is fired again will the craft be able to change speed and direction. On Earth, objects are affected by outside forces that slow them down and eventually stop them. Even on very slippery surfaces such as ice, objects will eventually slow to a stop. Friction is the force that slows things down. Friction occurs when two objects rub together or try to slide past each other. If you rub your hands together quickly, you will find that within seconds your palms become warm. One of the products of friction is heat. The friction between your palms produces heat. Next time you go for a ride in the car or on your bike, feel the tires after you've stopped. The heat you feel is from friction produced from the car's brakes rubbing against the tires. Look at the soles of your shoes. You should discover that they're worn down. Where once new, clean treads existed, you probably have worn surfaces. So another effect of friction is to wear things down. The friction between your shoes and the surfaces on which you walk and run has affected your soles. Look at car and bike tires, and you'll also see evidence of wear and tear brought on by friction. So, friction slows down an object until it stops, produces heat, and wears the object down. To avoid the wear and tear of friction on cars, we use lubricants, such as engine oil, to make the engine surfaces slide easily past each other and cut down on heat. If we didn't have friction, things would be very crazy. For instance, the process of walking or running occurs because of friction between our feet and the ground. Without friction, a person at rest or at a standstill could not get moving. And objects that were moving would not be able to stop because they require friction between their surface and the ground to slow down. Here is a computer game for playing billiards. We can turn the friction level to a setting that is very close to zero. Watch what happens when the cue ball is hit into the other balls. All this motion and uncontrolled activity is a result of very little friction. The inertia of the balls keeps them moving in straight paths until they strike other balls or the sides of the pool table. Here is an illustration of inertia. This tablecloth is loaded with inexpensive china and glasses of water. Now watch as we pull quickly on the tablecloth. Inertia is responsible for holding the china and glassware in place. Now, you may not want to try this at home, so here is a version of that same experiment, but only a coin, a piece of cardboard, and a glass are required. Your mother's good china is saved. Here's another demonstration of inertia. A large rock is supported on this person's head. A piece of wood is placed on top, and a friend proceeds to drive a nail into the wood. Why no headache? Inertia. The rock doesn't want to budge. It absorbs the force of the hammer blows, and the person underneath survives unscathed. Now, let's consider the inertia of an object that is moving. When you are riding in a car and the vehicle goes around a corner, you feel like you are sliding off to one side. But actually, your body wants to continue going straight as the vehicle turns. We can demonstrate this with this ball and hand cart. When the cart turns, the ball rolls off. Now, let's step back and see what is really happening. When the cart turns, the ball continues to travel in a straight path. So when you're in a car and it suddenly turns, your body really wants to continue in a straight line. A spinning gyroscope will resist changing its starting position. It can be balanced on a string or small stand. In the weightless environment of space, the gyroscope works even better. So inertia explains many common everyday situations.